What defines inputs and outputs in logic gates? Imagine a busy kitchen where ingredients come in and a finished dish goes out. In digital electronics, logic gates are like that kitchen, with inputs and outputs playing key roles. Inputs are the signals or data fed into the gate, like ingredients in a recipe. These signals are usually represented as voltage levels, either low or high. A low voltage, close to 0 volts, stands for a 0 or false, while a high voltage, close to the power supply voltage, stands for a 1 or true. The inputs are what the logic gate receives from other parts of the circuit. Think of them as the choices you make before cooking. Each input can be either 0 or 1, and the gate processes these inputs based on its specific function. For example, an AND gate needs all inputs to be 1 to produce a 1 output. If even one input is 0, the output becomes 0. An OR gate, on the other hand, outputs a 1 if any input is 1. The output is the result after the logic gate applies its rule to the inputs. It is also a binary signal, represented as a voltage level. If the output is high, it indicates a 1, and if low, it indicates a 0. The output is what the circuit sends out to other parts of the system, like a finished dish ready to be served. In electrical terms, these signals are created by transistors or metal oxide semiconductor field effect transistors. These components act like tiny switches that turn on or off depending on the input voltage levels. When the switch is on, it produces a high voltage output. When off, it produces a low voltage. Most logic gates have 2 or more inputs, except for the NOT gate, which only has 1 input. All gates have a single output. The inputs and outputs are connected to other electronic components that help perform complex tasks like calculations or decision-making. In digital electronics, understanding what defines inputs and outputs helps us see how computers process information. Inputs are the signals coming into the gate, representing logical variables. The output is the signal generated after applying the gate's logic function. These points of data exchange are what allow digital systems to perform tasks like arithmetic, data storage, and control functions. In practical applications, these logic gates are used inside microprocessors, memory chips, digital signal processors, and embedded systems. They work together to perform complex operations, making modern electronics possible. Whether it's a simple decision or a complex calculation, inputs and outputs in logic gates are the foundation of digital technology.